Hello, Algebra 2 folks, and welcome to a new function called Piecewise function. You need your notebook, a piece of graph paper, a calculator, and a pencil, and we will get started. The first thing we want to talk about is that learning target. It's really important that we understand what we're doing from day to day. So today we are going to be given a piecewise function, and then you're going to be able to evaluate for a specific x value. Now, before I go ahead and show you how to do that, let's talk about what a piecewise function is. So a piecewise function is a function that's made up of pieces of different functions, which are a result of their different domains, or we can say x values. So basically, we have multiple functions and pieces of them on the same coordinate plane. So we might have part of this line, part of this V, another part of a line, okay? And they're all on the same coordinate plane, and we call it a piecewise because it's like pieces to a puzzle. When would we use a piecewise function in real life? That's if you were working at a job. And say you're working at a job and you make $8.50 an hour. Well, you make $8.50 an hour until you hit 40 hours. Now, some of you might work overtime, and if you work overtime or over 40 hours, you actually would make what's called time and a half, or overtime. So if we were going to talk about what happens from 0 hours to 40 hours, you make $8.50. But then all of a sudden, we switch the way we calculate our pay if we work overtime, and then that becomes a new function. So the two functions that we would have are, we would have $8.50 per hour for 40 hours and less. But then at 41 hours or 40 and a half hours or 40 and a quarter hours, if we work over 40 hours, your employee has to pay you time and a half, which would calculate as $12.75. Okay? So if we were to use these two functions and then write it in a piecewise equation, you will notice that we will have two different equations happening here. So a piecewise always tells you y is equal to something, or you can say f of x is equal to something. And then it tells you the two functions it includes. This is the first function, and so these guys over here are your functions, okay? So they're what you're going to graph on your coordinate plane. These guys over here are what we call your restrictions. Okay, so you only graph the function at this restriction. Okay, this doesn't mean any shading. It doesn't have any shading or dashed lines. They're all solid lines, but we only graph this function from 40 and below. Okay, and then this function would be graphed when we hit anything above 40. So when I draw this line, I'll draw my line, and then at the end I'll have a solid dot because this means a solid point. And then for this graph, when I started at 40, I'm going to start it with an open circle because this means an open circle. So this means a solid dot, this means an open dot. Now, you still are going to have a solid line. There's no dashing lines, there's no shading. The only thing different is how we put our dot on our graph. Will it be closed, so we stop and have it included, or will we stop and have it not included? Okay, and these will start making more sense as we go along and talk about piecewise. So I don't want you stressing out so much right now because we're going to spend 8 or 9 days on this. And this is just day 1. Okay, so now this is my piecewise function. So Let's talk about what this is talking about. These guys are my functions. These are my graphs, okay? And this part is my restriction. Okay, these are the x values I can use. So don't think of it as dashed lines, solid, and they're all solid lines. I'm just going to tell you that you would graph this function anywhere less than 3, and you would graph this function anywhere greater than or equal to 3. And we'll worry about what the graphs look like and writing functions a little bit later. Let's just talk about how I would evaluate this. So I want to find f of 5. Okay, so this is my function, f of x, and I want to find f of 5. Well, remember what that 5 represents? That 5 represents the x value. Okay, so this tells you what restriction I'm talking about. So we want to go to our restrictions and find out where 5 fits in. So is 5 less than 3, or is 5 greater than or equal to 3? Well, in all of my math career, 5 has never been less than 3. So I would say that 5 is greater than or equal to 3. So if 5 is greater than or equal to 3, what we do is we go to this function because it fits that restriction and plug 5 in. So 1/2 times 5 plus 1 would be 5/2 plus 1, which would be 3.5, which would be 7/2. So when f is 5, you get 7/2. Okay, let's try -4. So now we have to go up to our restrictions and find out where -4 would belong. Well, -4 is less than 3. So I would use this function. So I would say my x value is -4. And I would plug it into this function everywhere I see an x. And then I would evaluate that. So -4 plus 4 is 0. The absolute value of 0 is 0. 0 times 2 is 0. And 0 minus 2 is -2. So f of -4 would equal -2. And that would be my answer. Okay, now let's do f of 3. Let's do purple. So where would my restriction be? I come up to my restrictions and I find out where my x would be 3. Well, I know that x is either greater than or equal to 3. It's not less than 3, it's equal to 3. So I would use this function again. So I would say 1/2 times 3 plus 1. So that would give me 3/2 plus 1, which would give me 2/2, which that would equal 5/2. So f of 3 is equal to 5/2. So basically all I'm doing is finding my x value and where it would work in my restriction. Once I find out where it works in my restriction, that's the function I plug it into. Okay, let's try it again. Oh, this time the piecewise function is 3 parts. It has this part, this one, and that one. Okay, so I have 3 functions, okay, and I have different restrictions. So remember, these are my functions, these are my graphs, and these are my restrictions. These are the x values I would use for each particular graph. So this graph would only graph where it's less than 4. This graph I would graph between 4 and 7, but not including 7. And this graph I would graph where x is greater than or equal to 7. So these are where I would graph these functions. Okay, now if I'm evaluating, I find the x value that goes along with that restriction. So if x is -2, I have to find out where -2 falls. Is -2 greater than 7? Is -2 between 4 and 7? Or is it less than 4? Well, I think -2 is less than 4, so I'm going to use this function. So I will take 2 times -2 squared plus 1, and I get 2 times -2 squared is 4 plus 1. 2 times 4 is 8. 8 plus 1 is 9. And so f of -2 would equal 9. All right, now I'm going to take a different color here and look at 8. Where would 8 fall? 8 would be anything greater than or equal to 7. So it would be this function. And my y value when x is 8, I have no way to plug 8 in there anywhere. So the y would be 3. So f of 8 would equal 3. I have nothing to plug it into. That's going to be the y value always. This is a horizontal line, by the way. So if you have a horizontal line at 3, then 3 comma 8 would be, or 8 comma 3, the y value would be 3. Okay. Then let's take another color here and do 4. And now I need to evaluate where f is 4. Well, this is greater than 7, so it's not here. This is between 4 and 7, and that includes the 4, so I would use this graph. So 4 times 4 plus 2/3 would be 16 and 2/3. So f of 4 would equal 16 and 2/3. 16 plus 2/3 would be 16 and 2/3. All right. Let's go ahead and draw this graph out. And notice this is what a piecewise graph looks like. Notice it has 3 different parts to the graph. Okay, so it has 3 functions. This function, so function, let's just call this part 1. It has this function, which is part 2, and it has this function, which is part 3. So it has 3 pieces of 3 different graphs. And notice it has open circles and closed circles. Closed circles means it's included. Open circle means that value is not included. Okay? So this has a lot going on, but this is what the graph of a piecewise function would look like. Now, if I asked you to evaluate looking at a graph, now make sure you draw these points right in your graph book, in your notebook, or whatever book you have. If you don't have a notebook with graph paper, use a piece of graph paper. Now what we're going to do is we are going to evaluate the x value using this graph. Okay? So I want to find f of -6. So this is my x value. So I'm going to go to my x values and I'm going to find -6. Here's -6. Then what I'm going to do is I'm going to try to find out what the y value is when x is -6. So there's no graph down here, but there is a graph up here. So what I'm going to do is I'm going to find my way up to that point, and on this first function is where I find my y value, which is 5. Okay, now I want to find f of 1. So what I'm going to do is I'm going to go to the x-axis and I'm going to find my 1. Here's where 1 is, and I'm going to find the y value that works. If I come down here, this y value is not included. So this is not the answer, okay? This has an open circle, which means not included. But if I go up to the top, I see a solid point. And that solid point means it's included. So when I have an x of 1, my y value will be 3. Not negative 3, but positive 3 in this case. Okay? Now I need to go ahead and try f of negative 1. So I go to negative 1. There's no function up here, so I'm going to go all the way down to this point. And on the second function, negative 1 happens to hit whatever value this is, and that would be negative 7. Okay, so when we're evaluating a piecewise, we're trying to find what x value works. So I find the graph or the function that includes that x value, and I either evaluate it using PEMDAS, or I use my graph and a visual to find out where the value would be at that x value. Okay, that's all I have for you today. I hope that you have a little bit of understanding of what a piecewise is, and at least you know how to evaluate them. I hope you have a great evening, and we'll be back to practice tomorrow.